Hello everyone. In this part 6 of limits and derivatives, I'll explain you about the derivative of a function using first principle. First, we will move to this concept. We have to understand the meaning of differentiability. Differentiability of a function at a point. If we are going to say that a given function is differentiable at any point, then simply we are going to say this, that if we will draw the graph of that function, and at that point where we are going to find the differentiability of the function, if we can draw a unique tangent with finite slope, then the function is differentiable at that point. Statement wise, let f d to r be a function where d is an open interval in R and let C belongs to D, then f is said to be differentiable at x is equals to C. And we will say this is only in that case if limit h tends to 0 fc plus h minus fc upon h. And this is the rule for the first principle also to find out the derivative. Now this is for a particular point, but as a whole, if a function is differentiable in this complete graph, then to find out the derivative using first principle, we will convert this rule in the form of limit h tends to 0 fx plus h minus fx upon h. Because if we are using the first principle and we are finding the derivative, we are not calculating at particular point. That time we are saying that the function is differentiable on whole. And derivative of a function, suppose this is fx, if we will consider y is equals to fx, then the derivative is represented by dy by dx, or you can say d by dx of f dash x. Or we can say f dash x. This is the mathematical notation for this part. Or if you can write down, you can write down in this way also, d by dx fx or f dash x. These three notations are there. Now let's start to do the solutions of few questions to understand the concept. In question number 1, find the derivatives of the following function using first principle. So in A part we have to find the derivative of x raised to power n. How will we start? We will consider let fx is equals to x raised to power n. Then fx plus h will be x plus h whole raised to power n. Using first principle, we know very well f dash x is equals to limit h tends to 0 fx plus h minus fx upon h. This is the rule for the first principle. Now put the values, limit h tends to 0, but this become x plus h whole raised to power n minus x raised to power n upon h. Now we will consider let x plus h is equals to t. Now if h tends to 0, it implies that t tends to x. It means what this become? Limit h t tends to x, x plus h means t raised to power n minus x raised to power n upon what this become? T minus x. Now here we are going to use that rule, that limit. What is the rule? Limit x tends to a, x raised to power n minus a raised to power n upon x minus a is equals to n into a raised to power n minus 1. Same rule we are using here. So what this become? This become n into x raised to power n minus 1. So this is the derivative of this function, and later on we will use this rule directly. Now in B part we have to find out the derivative of 10x using first principle. So we will consider let fx is equals to 10x. Then what we have, fx plus h is equals to, wherever is x we have to substitute x plus h. it means this become 10x plus h. Now, according to the first principle, f dash x is equals to limit h tends to 0, fx plus h minus fx upon h. Now put the values. Once you will put the values, this become limit h tends to 0, fx plus h means 10x plus h minus 10x upon h. Now split this 10x into in the form of sin x upon cos x. It means this become sin x plus h upon cos x plus h minus sin x upon cos x, and what is this upon h. Now once we will take the LCM, after taking LCM, this become f dash x is equals to limit h tends to 0, and this is sin x plus h minus sin x plus h into cos x minus cos x plus h into sin x, and in upon we have h into what is this cos x into cos x plus h. We know very well in numerator we are going to get the identity sin a cos b minus cos a sin b. It means this is sin a minus b. It means this is minus x h, and this is cos x plus h. Now this become, now split this, transfer this limit separate. It means this become limit h tends to 0 sin h upon h, and 1 upon limit h tends to 0 cos x into limit h tends to 0 cos x plus h. It means what this become, we have now after putting the limit 1 upon cos x into cos x, it means this is sec square x. Therefore we can say in general d by dx of 10x is equals to sec square x. So this is the way in which in between we have to use the rules whatever we learned to evaluate the limits. Now let's start to do the solution of C part. In this C part we have to find the derivative of under root sin x. So first of all we will consider let fx is equals to root sin x. Let fx is equals to root sin x. Once you will consider fx is equals to root sin x, then what this become fx plus h. Fx plus h means root sin x plus h. Now according to the first principle, f dash x is equals to limit h tends to 0 fx plus h minus fx upon h. This is the part. Now this become limit h tends to 0 fx plus h means root sin x plus h minus root sin x upon h. How will we do the put the limits? Because this is the root part, so we will do the process of rationalization. In case of rationalization, this is root sin x plus h minus root sin x. Now multiply and divide by root sin x plus h plus root sin x upon h into root sin x plus h plus root sin x. This is the part. Now limit h tends to 0 sin a, this is a minus b, a plus b. It means this become sin x plus h minus sin x upon, as it is, what is this, h into root sin x plus h plus root sin x. Now sin c minus sin d. What is the rule? Rule is 2 cos c plus d by 2. It means this become 2 cos 2x plus h upon 2 sin c minus d by 2. It means sin h by 2. To make it h by 2, multiply by this 2 and divide by 2, and this term as it is root sin x plus h plus root sine x. This is the part. Now, if we will put the limits, then what we will get? We are first of all this 2 to cancel out. If we will put the limit here, then what this become? This become cos x. Sine h by 2 upon h by 2 is 1. And here what this become? Root sine x plus root sine x. And root sine x plus root sine x means 2 root sine x. It means the derivative of this one is cos 2 root sine x. So this is the way to find out the derivative of a given function. Now let's start to do the solution of question number 1 D part, in which we have to find the derivative of x sine x. Now for this, let fx is equals to x sine x. Let fx is equals to x sine x. What this become? Fx plus h. Fx plus h become x plus h into sine x plus h. Now using first principle, we know very well f dash x is equals to limit h tends to 0 fx plus h minus fx upon h. Now limit h tends to 0. What this become? This become x plus h into sine x plus h minus x sine x. Now keep the terms of x1 separate. It means this become limit h tends to 0. X is common here. But this become sine x plus h minus sine x. And what is left? Plus h sine x plus h. Plus h sine x plus h. This is the part. And what is this? H only. Now here you apply this identity. Sine c minus sine d. What is this? 2 cos c plus d by 2. It means 2 cos c plus d by 2 means 2x plus h upon 2. And this is sine c minus d by 2. It means this is sine h plus, what is this? H into sine x plus h whole upon h. This is the part. Now keep it separate. Once we will do in this part. So what this become? Limit h tends to 0. Because x is constant, take it outside. 2 cos 2. This become, this is the part 2. Now 2 cos 2x plus h and upon 2. This is sine h by 2. So sine h by 2, make it h by 2, multiply by 2, divide by 2, 2 to cancel out, and plus limit, because here h cancel out, limit h tends to 0, sine x plus h. Now look at this thing. If we will put the limit here, this become cos x, sine h by, limit h tends to 0, sine h by 2 1. And this is, if we will put limit h tends to 0, but this becomes sine x. So the answer is f dash x is equals to x cos x plus sine x, or you can write down fx is equals to sine x plus x cos x. So this is the way to find out the derivatives of functions using first principle. Do the practice. Very important topic. Don't forget to give the answer of this question in comment box. Thanks and God bless you.